All right, this is Pre-Algebra lesson 2.1. Properties of numbers. This lesson is not a super difficult one, at least the way I teach it. Here's the deal. You know most of this stuff. You just may not know that you know it. I'll explain. There are different, I call them rules. There are properties of numbers in that, okay, here's the deal. What is 5 plus 3? 8, okay. What is 3 plus 5? 8. See, that's a rule that you know that. You know that if you take two numbers and you add them together and you switch them, that the answer is still the same, right? What if I have 5 plus 3 plus 2, and then over here I have 3 plus 2 plus 5? What's the answer? They're both 10. What I've done is, see, one thing you're allowed to do is you're allowed to, if you have a string of addition or subtraction. We've already talked about this. Subtraction is just, what is subtraction? What is 4 minus 2? Okay. What is 4 plus a negative 2, right? Subtraction is simply, it's addition, right? Subtraction is addition, right? You can make subtraction addition. So anytime you have a string of addition, which includes subtraction, anytime you have a string of addition, I'm allowed to move the numbers around anywhere I want to, and the answer is going to be the same. That is called the commutative, commutative property of addition. What does the word commute mean? What's commute mean? To travel or move. I commuted to work today. I moved from my house to my work today. That's what commute means. So the commutative property means you're allowed to move the numbers around and the answer doesn't change. Right? Does that make sense? Okay. That's the commutative property of addition. There's another thing called the associative property of addition. And what that property says is this. If I have 4 plus 3 plus 2, that is the exact same thing as 4 plus 3 plus 2, except on this one over here, I'm going to add 3 plus 2 first. What is the difference between this and this? What's the difference in answer? What's the difference in answer? Nothing. They're identical, right? The associative property of addition says that I can choose which order I add them in. It doesn't matter what order I add them in, right? So if I have one that looks like this, 4 plus 3 plus 2 plus 1, that's the same thing as 4 plus 3 plus 2 plus 1 as me going like this. Or 4 plus 3 plus 2 plus 1 is the same as this. Or, do you see what I'm saying? Like, it doesn't matter which one I do first. It's all going to add up to 10. Does that make sense? So I can move them around if I want to. I can also choose to add whichever ones first I want to. It doesn't matter. That's called the associative property of addition. Now, I don't particularly care that you memorize those words. You just, what do we think I care about? That you know that you're allowed to do that, right? When does this matter? Why does it matter that we're able to do this? What if I gave you this question? Can you quickly do this one in your head? Why can you quickly do this one in your head, Sheena? I'm going to add 13 and 87 because I know that those two add up to 100. And then 100 plus 49 is 149. Super easy. Otherwise, I've got to go 13 plus 49, right? 62. And then add that to 87. And you see what I'm saying? But because of the commutative property of addition, right, where I actually moved these guys, right? I moved 13 plus 87 plus 49 and go, oh, that's 100, and 100 plus 49 is 149, easy. I know I'm allowed to do that. Make sense? Okay. There's another basic type of addition property, and it's real tough. You ready? And you've known this one since kindergarten, maybe first grade. If you have a number and you add 0 to it, what happens to the number? It stays the same. This is called the identity property, okay? This is the additive identity property. Identity means this. If you add 0 to a number, it doesn't change its identity. Does that make sense? So think of it like that. It's called the additive identity property because when you add 0 to it, it doesn't change its identity. Y'all understand what identity is? Like who you are, like it's what you are. Okay, so you know that if you add 0 to a number, it doesn't change. What if it's negative 38 plus 0? What's the answer? Negative 38. It doesn't change, right? Okay, you know that. Okay, now, they also have I have a question. What is 5 times 3?
15.
What is 3 times 5?
15.
So there's also so hold on. Again, I moved them around. As long as I have a string of multiplication, what am I allowed to do? I can move them around. So there's a commutative property of multiplication too. Does that make sense? There is a commutative property of multiplication as well, just like addition. If there's nothing, now listen, am I allowed to do this? If it's 5 times 3 plus 4, can I go 3 times 4 plus 5? Is that the same thing? No. It's only if it's all addition, I can move them around. Or if it's all multiplication, I can move them around. But if you start mixing and matching, you can't do that. Right? You can't do that. So, what is this called? What if I gave you 6 times 3 times 2? And then I showed you, I said that is the same as 3 times 2 times 6. What property are we talking about here? This is commutative property, right? Because I took the 6 that was on the left here and I moved it over here, right? I moved it to over here. It's still 6 times 3 times 2 is the same as 3 times 2 times 6. That's the commutative property of multiplication, right? Makes sense? There's also the associative property of multiplication. What is this? 3 times 2 times 1 is the same as 3 times 2 times 1, except I'm going to go like this. What is 3 times 2? 6. 6 times 1 is 6. What is 2 times 1? 2. What is 3 times 2? 6. On this one, I just changed the order that I did them. I'm not moving anything around. I just changed the order. It's still the same, right? This is the associative property of multiplication. Doesn't matter which one you do first. There's also a multiplicative identity property. Everybody say multiplicative. It's a weird word, right? Look at it. It's on the top of page 67. Multiplicative. That's a weird one. It looks like you want to say multiply, but it's multiplicative, right? Everybody say it again. Multiplicative. Multiplicative. The multiplicative identity property. What's the difference here? The additive identity property says that if I have 7 plus 0, what? 7 plus 0, it keeps its identity. It keeps its identity. That's why it's called the additive identity. The identity property of multiplication, which is called the multiplicative identity property, is this. 7 times 0 is 0. Any number times 0 is 0. 0 of anything. If I have 0 anythings, I have nothing. Right? So the multiplicative identity property says if you multiply a number by 0, the answer is 0. You know these rules, you just may not have known that it's called the multiplicative identity property. Make sense? And so there's really nothing more to do here. The only thing I would say is this, is that now that you know the names of these things. You just need to remember what's the best way of doing it. What if I have this? See, first of all, how many of you know what 5 times 13 is just right off the bat? Most people don't know their 13s. Most people don't know their 13s, right? And even if I did, that wouldn't be the best way of doing this. What would be the best way of doing this in your head, Amy? Right, 5 times 20, which is 100. 100 times 13 is 1,300. Does that make sense? I'm allowed to do that. And that's why knowing these properties is so important, is so that you know you're allowed to move stuff around to make your life easy. What if I gave you one that was not that simple, and it was 5 times, 2.4 times 10? How many of you want to do 5 times 2.4? I don't. But what I could do is, what's 5 times 10? 50. And then all of a sudden now, go ahead. Probably. That's good. Especially if I gave you one like that. Because 5 times 20 is 100. 100 times 2.4 is 240, right? Move the decimal over 2 spaces. My whole point is that you need to be able to understand that I'm allowed to do that. Move things around. Make your life easier. You don't need to do it in order if you don't need to, if you don't have to, right? Figure it out. What if I gave you this? You could go 13 plus 7.6 and make it, or what you see, you could do what? What is 13 plus 7? 20. What's 7.6 plus 2.4? 10. 20 plus 10 is 30. Right? Knowing that you're allowed to move stuff around and do things, just like if I did this, 8.7 times 5 times 2. Some of you might decide to go 8.7 times 5, and oh man, that would take a while. And then you double it, or you could go 5 times 2 is 10. 10 times 8.7 is 87. Do you see what I'm saying? This is you use the associative property by going like this, which you're allowed to do. Make sense? Anyway. You do whatever, right? As you follow, as long as you follow the rules. When I say the rules, as long as you follow the properties, right? As long as you use the properties, you do whatever you want in life. Okay, I'm going to give you your homework. Super simple. Your homework is and